a little bit about the impact of good data design, data curation. We can talk about some of the major bottlenecks in achieving true AI, and then end up with where is AI going in the future. So I'll stop sharing the screen and we'll just talk about it. Over to you.
Yeah, so I mentioned that one lesson we can learn from software engineering is that sometimes a bit of effort up front can save you a lot of downstream effort. That's certainly true. A second impact, a lesson learned from software engineering, is also that reuse is essential. And in our current development world, we could not do our jobs without massive reuse of languages, libraries, and frameworks that incorporate things that are common that we don't need to write from scratch, whether it's an Apache web server or a Java library, any number of different components. Most of the software we deliver to our customers is not software we wrote. That's the only way that we can do our jobs today under these extreme time pressures and expectations of developing very sophisticated software. But in data, this doesn't happen. People invent their own data designs from scratch, their own data elements from scratch. What we need, I think, are very large reusable libraries of data and the definitions of those data elements. And that's really what has been at the core of my career for the past 20 years. If we could make that a common practice, then not only would we have better data designs with much clearer definitions and more shared understanding amongst developers that may come and go on a team over time, but we would also have a way to speed up that process. It's not enough to say, great, do a sort of academic effort where everything is perfect right from the start. That's not realistic. We need something that supports change. Change is an absolute reality. It's a fact of life. And in the face of that change, we need ways to speed things up. And just as in conventional software development, one of the ways we speed things up is through large-scale reuse. Yet most people doing data design are, their reuse consists of they come onto a project and they use what's already there and maybe they modify it. But if a whole new data set comes in or a new project starts, people generally create their database, their schema, their data warehouse, really all from scratch. We need to get away from that. We can speed up this process and make the results better by reusing large and formally specified models of what data means. We can head off this problem of data drift and the incomprehensibility of data drift by members of teams over time that lead to a lot of wasted effort and more importantly, lead to wrong results, right? By not understanding the data and having AutoML or any other sort of approach operate on it, we're going to get results we haven't anticipated. And we keep seeing, as we mentioned before, a lot of headlines about this sort of thing. If we don't understand that our data is biased in a particular way, and we trust the results, and we shouldn't, well, that can have a big impact on society.
Yeah, yeah. You know what, I can draw a parallel to this in the machine learning world today, as we call it, right? I mean, there are a whole bunch of data scientists trying to custom build models. They're trying to use services which are ready to go. But I believe there's a big movement towards pre-trained models, models which can reduce the workload on our data scientists or developers, pre-trained models which have a basic foundation behind it. In fact, I think Stanford has coined a term called foundational models for these foundational models. And GPT-3 and OpenAI, these groups, all the open source groups are now leaning towards that, saying, one, we are trying to make life easier for the data scientists, but we are also trying to reduce the time it takes to go through these innovation life cycles that we are experiencing. And we have good foundations where we're using large data sets and then consuming that, through foundation models that will help everybody. So I think there is a certain movement happening there. It is required even for the data engineering world. This is required, as you rightly said, in any product or any project work, that you start from the first step and make sure that your foundations are good when you go through. In fact, I'll just bring up one more story here, which is from one of our friends, mutual colleagues. They have an excellent idea, disruptive idea for the world today, where they can use some of the AI elements and software. They can release product out there. It can help in disrupting the staffing, resourcing world out there, as you can guess what I'm talking about. But the whole thing is they're going with something very minuscule in an approach that maybe doesn't help them scale up or grow faster. And that's a problem I think almost every SaaS company and every platform as a service company, everything as a service company is facing today, that they start with one mission and objective, but finding scale, finding diversity, finding a way to move it up the chain to more broader, more revenue making, profitable ventures requires a little bit more of that visionary or architectural thinking. So I personally agree with you. Maybe if you can talk a little bit about what your thought was when you started with ontology and the basis of ontology, maybe that will help in the whole scope, the grand scheme of things, right? How we can help machine learners and data scientists to do a better job by having the right context and the word kind of, word net backing right behind it.
I think you've hit upon an important point also, that we could connect maybe to certain modern business lingo, right? This notion of the minimum viable product is a tremendously valuable concept for keeping people focused on not going off on a wild goose chase and over engineering things. But I've heard that phrase used as a justification many times to shut down exploring the issue of then another major business buzzword: how do we scale?
Yeah.
Right? And if you don't acknowledge that both of those pressures are present when trying to develop a product, you'll either have one extreme or the other, either a product that never reaches market because you didn't focus on the minimum viable product, or a product that breaks or costs 10 times more to develop version 2 if you don't have some sort of planning or consideration for how are you going to scale. And it's important to remember that there are multiple dimensions of scaling.
Yes.
Right? It's scaling to maybe a larger market, a more diverse market, a more diverse set of circumstances or needs or requirements. You can have scaling to massively more amounts of customer or revenue or purchases. There's multiple dimensions to this, and they need to be considered. And all of these things have to be balanced together in achieving a business that actually works. So, nobody likes to put in extra effort into something that doesn't give them functionality. And yet there are certain kinds of upfront effort that seem to be recognized as having a cost savings, and others don't. In software, back when I was starting my career, there were lots of people that were talking about how they wanted to just not use any frameworks and create everything from scratch. That was feasible in the 1980s because we were building as a programming community things that were comparatively small compared to today's software deliveries. Maybe they could get away with it back then, but I think it generally wasn't recognized until it became a crushing issue that it simply was impossible to write everything or nearly everything from scratch, at least other than the operating system. Of course, even from the origins of programming, we were all reusing the operating system. It just took a while for people to realize that there were these other things that we could reuse and invest in that would make our jobs feasible, allow our software to scale to the level that it's at today. And so this is an important consideration to remember. How can we put in a judicious amount of effort supported by tools, automation, and reuse to make sure that we can scale in the long term?
Right. And those tools should be interoperable. They should be easy to use. Those tools should be something that builds on top of each other like a Lego block. I always think of this as Lego blocks approach. I don't know whether you heard about my MLOps automation talk there, but that's what I was trying to talk about, that you can take GitHub Actions and add value there. GitHub Actions has got great workflow capabilities. But similarly, we can think of all kinds of tools in the AI space, machine learning space, NLP space. I heard you're going to go talk at the San Jose State University. You're going to speak and teach students about NLP in the next semester. So congratulations on that. And this is the core message I think we should give the developer community, that where is AI going in the future? Where are we going towards, right? We need to ensure that AI is built in a responsible way, in a human-centered way, but reusing, automating, making life easier for everybody to continue their job and keep releasing product out of product and, have kind of disruptive innovation S cycles coming out of it. And that will happen if we think the right way, if we have the right thinking, the right tool set, the right experiences in mind, and we make sure that data scientists are working with that understanding that these tools will be available to them, whether they use something like MLflow, an open source tool set, or whether they use Kubeflow or something else, right, for operationalizing it. But it is possible, but it requires learning, an open mindset, and then, the ability to kind of adapt, right, based on the situation, like you said, reuse previous work. And I see transfer learning becoming very popular in the machine learning space. And similarly, transfer learning in the data space would be wonderful to have.
Another interesting point that you bring up is that people are always on the search for something that is easy. And yet a lot of these things are not easy and they're irreducibly not easy. There's a great quote from Einstein of things that should be as simple as possible, but no simpler. Right. And another good quote that I like was from Mark Twain that said, to every big problem, there's always a simple solution that is wrong. Right. So people certainly have been looking for a long time for solutions to the problem that programming is challenging. And I think that what we've come to as a conclusion for general purpose software development is that, yes, it's difficult. It's irreducibly difficult, but we've developed tools and libraries and processes and education to make that effort reasonable, because we've already made it about as simple as it can be for the broad case. Although people still are developing very domain-specific tools or situation-specific tools to try to do low or no code stuff. That's great if your problem fits a structure that somebody else has already examined and solved in depth. But I think it's fair to say that most problems are actually not like that, and that's why the world employs so many developers. The challenge now is to realize what other problems are there out there that are just being ignored or oversimplified at great cost later. And I think one of those problems is the design and definition of data. It's just not recognized as a problem. It's sort of an afterthought. We as computer scientists are taught very early on how to create schemas and databases. It's part of our day-to-day effort. And that part of data science has not really changed very much in a very, very long period of time. Yeah. Whether you're a data scientist doing advanced ML, or you're somebody doing a SAP implementation, you're still charged with thinking up a set of labels, a few relationships, and having some intuition about what the possible values can be, but not really specifying that outside of some checks, say in procedural code or bug checking, not in any sort of objective, consistent, very process-oriented way. I think that needs to change.
I agree. And so, just to end today's session with a positive note, I think the true AI is not too far away. It is far away, but it is not too far away. And we'll have three types of audiences to cater, right? The people who are real computer scientists, data scientists, people who really are going into building new models or reusable code. Then we'll have those low code players who want to build on top of reusable assets and artifacts, services like cognitive services. Microsoft Azure has some great, AWS has, everyone, Google has some great cognitive services with Vertex AI coming up. So all of them have that, but that low code audience, will will need that to keep growing and building up on top of that. And then we have the no code ones. We cannot forget those two. The no code developers or the no code folks will also need the right amount of tooling and support and help so that they can stay productive and keep building on top and truly build that true AI that people are going after, which will augment and assist humans in doing a better job of what they're doing today in the world.
And whether it's what you've talked about with the Stanford's research environment developing foundational models, or whether it's about a low code or no code solution, those are still just components.
Yes.
And those components themselves have a data interface. And if we don't have a specification or really strict information on the intended meaning of those interfaces that we have to those components, we can have all of the speed up in the world, all of the sort of brilliant application to one portion of the problem, but very few problems, business problems, customer problems, can be solved by just sort of one black box component. Things exist in an ecosystem. That ecosystem has a set of interfaces in it. And if we don't know what those interfaces mean, we don't know what data is being sent from one component to another, whether it's a low code component or a painstakingly handcrafted programmed component or some sort of large scale machine learning solution, then we've got a problem if we have in a sort of impedance mismatch in what those interfaces mean from one component to the next. We can't escape this problem.
Yeah, and that can lead us to dangerous AI or the negative side of AI, which we should all try to avoid. So with that, I'm going to just wrap up the session. Thank you for the time, Dr. Adam Pease. I appreciate the thoughts and the kind of constructive suggestions on how developers and data scientists can think in this field. I would love for people to go and check out Dr. Adam Pease's website, ontologyportal.org, and then Sumo as an open source approach to solving this kind of problem. I love it. I feel, yes, it is something that will be foundational in nature and help a lot more people coming forward, in building contextual and human-centered AI. Thank you for your time. Appreciate it.
Thank you. It's been a pleasure.
Thank you, guys. Yeah.